Are you ready to dive into the world of applied biochemistry? This video will guide you through the essentials of mastering biochemistry in a medical context. From understanding reactions to exploring genetic engineering, let's begin this educational journey. This assignment carries 6 credits at Level 3. It requires independent completion, covering 4 key learning outcomes. Each section includes specific word counts. Assessment criteria range from 1.1 to 4.2. Adhering to these ensures a comprehensive understanding. Only one formal submission is permitted under these regulations. A resubmission is allowed if criteria are unmet, but only to pass. No draft review or pre-marking is allowed. This ensures fairness, integrity, and consistency. Your work must reflect independent academic performance. Attend tutorials and ask targeted questions for clarity. Understand command verbs like define and explain. Seek guidance on structure and referencing. Review grading descriptors for pass, merit, and distinction. Strong performance requires explicit criteria coverage and scientific accuracy. Define anabolic and catabolic reactions clearly. Distinguish between hydrolysis and condensation reactions. Use chemical equations and examples to illustrate. Describe chromatography and biochemical testing methods. This understanding is crucial for practical applications. Paper chromatography can identify amino acids like aspartame. Chemical tests for starch and glucose use iodine and Benedict's reagent. Describe reagents, methods, and observations clearly. Include labeled diagrams for better understanding. These applications solidify theoretical knowledge. Relate enzyme structure to biological function. Explain the lock and key hypothesis. Discuss competitive versus non-competitive inhibition. Use examples and diagrams for clarity. This knowledge is vital for understanding enzyme activity. Interpret graphs showing temperature and pH effects on enzymes. Identify optimum temperature and pH for enzyme function. Explain denaturation and changes in the active site. Apply reasoning to digestive enzymes like pepsin and trypsin. This analysis is key to understanding enzyme behavior. Explain the use of plasmids in recombinant DNA technology. Include a medical application such as insulin production. Describe PCR stages, denaturation, annealing, and extension. Explain gel electrophoresis and DNA profiling. These processes are crucial for modern medical advancements. Merit requires a very good understanding of facts, theories, and methods. Distinction demands excellent depth and breadth of knowledge. Clear explanation of enzyme theory is essential. Strong application to medical context is necessary. This standard measures your grasp of the subject. Merit requires very good scientific accuracy and reasoning. Distinction demands excellent precision and insight. Effective interpretation of data and graphs is crucial. Consistent, correct use of scientific terminology is essential. These skills are vital for academic success. A logical academic structure is important. Accurate diagrams, tables, and graphs must be included. Independent research and correct referencing are required. Professional scientific presentation is essential. These skills enhance your overall academic performance. Ensure all assessment criteria are explicitly covered. Attempt all parts of the questions. Diagrams should be clearly labeled and original. References must be formatted correctly. Maintain academic integrity throughout your work. Clarify command verbs like define, distinguish, and describe. These verbs guide your response structure. Understanding them ensures you meet assessment criteria. It also aids in organizing your thoughts clearly. Mastering these verbs is key to effective communication. Review grading descriptors for pass, merit, and distinction. These descriptors outline the expectations for each grade. Understanding them helps you aim for higher performance. They provide clarity on what constitutes excellence. Use them as a benchmark for your work. Describe chromatography and its role in biochemical testing. Use it for amino acid identification like aspartame. Explain the chemical tests for starch and glucose. Detail the reagents, methods, and observations. These techniques are fundamental in biochemistry. Discuss competitive versus non-competitive enzyme inhibition. Use examples to illustrate each type. Explain how they affect enzyme activity. Diagrams can aid in understanding these concepts. This knowledge is crucial for grasping enzyme functionality. Interpret graphs showing enzyme activity against temperature and pH. Identify the optimum conditions for enzyme function. Explain how denaturation affects the active site. Relate these concepts to digestive enzymes like pepsin. This understanding is key for practical applications. Explain the use of plasmids in recombinant DNA technology. Highlight a medical application such as insulin production. Describe the stages of PCR, denaturation, annealing, and extension. Explain gel electrophoresis and DNA profiling. These technologies are transformative in medicine. A professional scientific presentation is essential. Ensure logical structure and accurate diagrams. Tables and graphs should be clear and informative. Correct referencing is crucial for academic integrity. These elements contribute to a polished final submission. Your work must reflect independent academic performance. This ensures integrity and fairness in assessment. Engage deeply with the material to produce original work. Avoid reliance on pre-marking or drafts. Strive for a comprehensive understanding and application. This is the conclusion of the video. Through understanding key biochemical concepts, you are now equipped for success. This journey covered reactions, enzyme dynamics, and genetic engineering. Apply this knowledge to excel in your studies and future medical applications.